Guys, we will talk about the estimation of pi with the rejection method. So let us start with drawing x uh, like this. So basically, I just want to draw the uniform samples between 0 and 1, and then I just print the histogram of x like this. Okay, hold on. I need to turn this one off first because I just want to to give you the blank canvas. Okay, so you can see here you have the value uniform values between 0 and 1 for x, and we do the same thing with y as well. So I will open this comment, and then I enable the y. Okay, so you have the same thing, 0 and 1. So if you want to draw the table, the table between this one, the two values, you can just use the data frame, and then you can combine them all together. So x will be the random value between 0 and 1. Y also the same thing. And then if the x and y within the circle, I will give the label in, and then outside the circle, and I give the label y, out. Okay, so here is the label how I can view. Though the circle it just simply the A and the B, and then you can have the sum of square A square and B square together. And then if because this one the value is within 0 and 1, and then you know that the circle the circle inside the circle meaning that's 1, and then outside the circle meaning that uh, more than 1. Okay, so if you draw this circle, it will look like this. G look like this. Okay, so you can see here, this is the circle from 0 and 1, and then for x, and 0 and 1 for y as well. So within this circle, you will get this label in, and then outside the circle will be out. Okay, so you can draw more than one, but it doesn't matter. It will, okay, let us see how it works with 2. I change this one to 2, which is 2 here. Okay, so you can see here x from 0 to 2 randomly. Y, I will keep it the same thing, 0 and 1 like this. And then within the circle, which is this part, which still red, and then the rest will be outside. Okay, and then that's it for the first part of the, let me put it back to the original. Okay, so now we talk about how to estimate the pi value here from this picture. Okay, so I will use the ratio between k between the red area, and then the whole thing, which is the total area in here. Okay, so the red area, which is like this one, you know that this if the radius of the circle is one here and one here, then of course the red area will be computed by pi, and then over time 1 and time 1 for the circle, and then the total area here, because this one is 1, this one is 1, so the actual number is 1. The area of the square is 1. Now this one is not this is not the whole circle. This one is a quarter of the circle, so you have to divide this one by 4. Okay, so the this, or if you want to, you just write 0.25, which is also 4. Okay, so now you have the this red, which is the red area over the O, will be the pi 0.25 pi in one hand. And then on the other hand, if you want to estimate this ratio, so the red area over O will be like this: k hat, which is the count of red points over the count of all red and blue points. Okay, so this is one way to estimate the ratio. We just divide the number of points, and that's it. And if you combine the two parts, assuming that k equal to k hat, and then you have this equation. So 0.25 pi equals k, which is almost equal to k hat, and then equal to this thing, right? And then this just mean that pi will be 4 times of this 100. So if you divide the whole thing by 0.25, sorry, it's a pi over 4. So you will get this pi 4 and times this one. And then if in our language it's just like this, 4 times the number of point in the frame red, and then over the number of point in the original frame. That's it. And then you can have it here already. So pi hat is it's around, okay, so because we try to estimate the pi by this this thing, so I suppose you use pi hat, or you use this one. Okay, and then this one is what exactly what we do in here. And then if you draw this title, you draw the title, or you draw the text inside this, it'll give you the number. Okay, I make the text bigger a little bit, or I make the picture bigger. Okay, so you can see here the number of sample is 5,000, and then the number the value of pi is about 3.1 for 5,000. Okay, so the next question will be like, so if we draw more samples, does it give you more a better value of pi? And then we need to do that. We need to do the next test in order to answer the question. Okay, so instead of using I will have to group the whole thing from here, from row 11 here all the way to 24 into another function. I call it test subject, and then I will use the n as the parameter of the test subject. So in this case, the test subject is 5,000, and we draw 5,000 sample. I will give a little bit indentation here for you to be aware of the inner part of the function. It doesn't matter for Power BI or R script, but it will matter for you to read this one. So I will return G instead in here, and then I will repeat this test subject with different numbers. So G1 will be the test subject with n equal maybe 1,000, and then 2 2 3 4 will be the five of the other number, maybe 2,000, 5,000, 9,000. Okay, and then you can print all of them all together by this function grid arrange growth graphical objects of which is a list of G1, G2, G3, G4, and then I will divide this drawing space into 2 columns. So n co equal to 2. Okay, and then there will. Okay, so you can see here there are different combination. This one you give you one 3.12. If you draw more sample, it give you 317, and then 0.6, and then 0.3 as well. So you can see from those tests, actually it's not that if you draw more sample, then you have more you have a better number, estimate, because the problem is if you draw more sample, but then it can go either side of the circle, right? So for example, if you draw here, some of them will get to this side, but some of them will get to the other side, and then as a result, the estimate will jump around the exact so sometimes it get bigger, sometimes it get smaller than the exact number. So we don't know the exact number until uh, we use the different method. So for the sampling method, it just because you can get the approximate values in a reasonable time. So for example, if you want to estimate the pi by the other method, it take you a few hours or maybe a few days, but then the sampling method can give you like a rough estimate about pi within maybe few minutes, and then that's why you choose to use sampling method instead of other methods. Okay, so that's it guys for applying the rejection method to estimate pi in this case.